Good day. So in this video, we're going to discuss the concept of anti-differentiation. Ito yung pinaka-fundamental natin gagamitin sa course ng integral calculus. So, if we examine the word correctly, or if we examine the word carefully, we have anti and differentiation. So basically, pwede nating isipin siya as the reverse of differentiation or dun sa ating differential calculus course, kumuha tayo ng derivatives. Dito, ibabaliktad natin yung process. So, given the derivative, hahanapin natin yung original function or kung saan siya nanggaling. So, we can start by defining what an antiderivative is. Okay, so we call capital F an antiderivative of the function small f on an interval I if f prime of x, or the derivative of capital F, is equal to small f for any x in that interval I. So for example, let's consider a simple case. Consider muna natin ngayon, let's say magbigay tayo ng function na ganito ang itsura, x squared plus 1. Na dito, hopefully naalala nyo pa kung paano kunin yung derivative nito. This one is simply equal to 2x. So hopefully there are no questions here. Now let us think, or let us ask, ito lang ba yung function na kapag kinuha natin yung derivative, equal yan sa 2x? So sana na-realize nyo na hindi. Kasi kapag pinalitan ko tong constant term na to, let's say x squared plus 3, if we get its derivative, this would still be equal to 2x. Isa yan sa mga kailangan na alala nyo na ang derivative ng constant ay equals sa 0. So, ibig sabihin, kung papalitan lang natin yung constant term, we can actually generate an infinite number of functions capital F kung saan makukuha natin derivative niya to be equal to 2x. So, let's say this one is 2021 kasi 2021 ngayon. So, this would still give us a derivative equal to 2x. So if we generalize that, if we have a function of this form for any constant c, we would get that its derivative is equal to 2x. Ibig sabihin, a function f, capital F, of the form x squared plus c is an antiderivative of 2x. So this explains, or this demonstrates, that differentiation and anti-differentiation are inverse processes. Or in symbols, we can actually express it or write it in this way. Na itong symbol na to, this one, this is the integral sign. Tapos itong constant c na to, we call this the constant of integration. Okay, so ito yung mostly pag-aaralan natin sa integral calculus. And of course, kung sa differential calculus, meron tayong mga techniques or theorems when we're getting the derivative of functions. In this video, we're going to focus on getting the antiderivative of what we refer to as algebraic functions. Ito yung mga polynomial, rational functions. Okay, so some theorems which may be helpful in solving the antiderivative of these types of functions. So yung first one, simply the integral of dx is equal to x plus c. By the way, hindi ko pala na-mention, we can read this as the integral of f of x dx is equal to capital F of x plus c. Or the antiderivative of f of x is equal to this one. Okay, so moving on. The first one is the integral of dx is equal to x plus c. The second one is if we have a constant multiplier a, pwede natin siya ilabas ng integral sign and get the get the antiderivative of f of x normally. The third one suggests that if we have a combination of functions, we can simply take the integral or take the antiderivative of each individual function. Now, it is worth noting na that holds true for sum or difference. Pero, hindi yan yung case for product or quotient of two functions. So, parang sa derivatives, di ba, meron tayong product rule saka quotient rule. In number 4, it's a combination of theorems 2 and 3. Pero this time, we're going to consider an n number of functions as well as constants. Okay, fifth one, ito yung feeling ko magiging favorite nyo, parang yung power rule or yung in getting the derivative. Ito yung kanyang counterpart in getting the anti-derivative. So basically, what happens here is ito lang yung inverse ng process na yun or i-reverse lang natin yung process na yun. So kung i-recall kasi natin, if we have f of x equal to x raised to n and we want to find its derivative, ito ay magiging n, bababa natin exponent, tapos yung exponent ng derivative niya ay mababawasan ng isa. So basically, binaliktad lang natin yun para makuha natin yung antiderivative or yung formula for antiderivative. Now that is provided that the exponent is not equal to negative 1. Kasi if the exponent is equal to negative 1, this is x raised to negative 1. So, sorry, nakalimutan ko yung dx. By the way, important yung paglagay ng dx dyan or kung anumang variable yung kinoconsider. If we simply apply the first part, this would be negative 1 plus 1 over negative 1 plus 1. So, x raised to 0 over 0, which is undefined, or we cannot have this. Now, if you would recall, kapag ang f of x natin ay ln x, ang kanyang derivative ay 1 over x. So, since inverse processes nga sila, no, ibabaliktad natin yun. Ito ay technically x raised to negative 1. So, kapag ganyan, ang kanyang antiderivative ay ln x plus c. Technically, that holds true, but if we would recall, ang graph ng ating ln x looks something like this. or it's only defined for x greater than 0. So, dapat positive yung value ng x. So, of course, it would be nice if our function or if our antiderivative will also be the same. Yung domain niya would also be the same. Okay? Kaya nilalagyan natin ng absolute value yung x para ma-make sure natin na define pa rin yung any value of x for that particular function. Okay, so in the last part of the video, we're just going to solve some examples na i-apply natin itong mga theorems na diniscuss natin briefly. Okay, first, we have the integral of 2 dx. So we can treat this as a combination of theorems 1 and 2. Pero diretsuhin na natin. This is simply 2x plus a constant c. Next, we have the integral of x squared plus 3x dx. We can separate the two terms. And then, we can apply the power rule. So this one would be x raised to 2 plus 1 over 2 plus 1 plus this one would be 3 times x raised to 1 plus 1 over 1 plus 1. Then, of course, plus a constant c. Now, technically, dito, if we treat it individually, meron plus c dito, meron rin plus c dito. Pero since it's just a constant, or it's just any constant, pwede nating pagsamahin or i-condense into one c. One constant c, I mean. Okay, so simplify. So this is x cubed over 3. And this one is 3x squared over 2 plus c. So, of course, this is our answer. Now, in the long run, we don't need to, actually, hindi naman required na ganito ka-detailed yung ating solution. Pinapakita ko lang yung application ng power. Pwede naman diretso na. Lalo na kung simple lang siya. This one is a little bit more complicated. So, integral of quantity 1 minus x over the square root of x dx. Okay, we can start by separating the terms. So, 1 over square root of x dx minus integral ng x over square root of x dx. Now, if we would recall, we can actually write this as x raised to negative 1/2 dx minus integral ng, and then this part here, this one is actually x raised to 1 over x raised to 1/2. So if we apply the laws of exponents, this is x raised to 1/2. So x raised to 1/2 dx. Then we can still apply the power rule. Kasi rational naman yung kanyang exponents. Yun. Okay, so continuing the process, power rule. Gamit tayo ng power rule. So x raised to negative 1/2 plus 1 over negative 1/2 plus 1. minus x raised to 1 half plus 1 over 1 half plus 1. Then, of course, our constant of integration. Okay, simplify natin. This would be x raised to 1 half over 1 half minus x raised to 3 halves over 3 halves plus c. Okay, we just have to write it properly. Yung fraction sa baba ay magiging 2x raised to 1 half minus 2/3 x raised to 3 halves plus c. Now, we can write it this way, or we can actually rewrite it as 2 square root of x minus 2/3 square root of x cubed plus c. Or pwede nyo pa to i-simplify as x square root of x. Okay, let's consider one last example for this video. So we have the integral of 4 minus 2x plus x squared over x. Sorry, nagkamali ako dyan ng type. Kaya sinulatan ko na lang. Okay, if we separate the terms, integral ng 4 over x dx minus 2x over x dx plus integral ng x squared over x dx. Then, if we apply loss of exponents first, or simplify, ito technically mga tatanggal. This one would cancel out. So we have 4x raised to negative 1 dx minus integral ng 2 dx plus integral ng x dx. So dito mas straightforward na ang paggamit natin ng power rule. This one, unahin natin yung last two terms, minus 2x plus x squared over 2 plus c. Then, if we would recall, since the exponent is negative 1, this would give us 4 ln absolute value of x. So, this one is our final answer. Okay, so ito yung ating first video sa pag-discuss ng antiderivatives. So in the next video, we're actually going to discuss how to get the antiderivative of transcendental functions, or ito yung mga trigonometric, exponential, and logarithmic functions.